Welcome back, Cro-Magnons. Today is June 22nd up to June 21st. Day 7, day 8, I don't know anymore. LeetCode every day. Back to Valid Anagram. And yeah, we couldn't finish this last time because I couldn't remember exactly what function call actually gave you the character code at a specific index. And I thought it was car at. I think it's car code at. So this problem should be no problem. We couldn't sort it before, but should be very much possible. I got some random ones lined up. I got some more to add, and then I got probably do some random ones after that. But I'm just gonna jump into it. Oh yeah, I didn't finish yesterday's problem. Well, I did finish yesterday's problem, but what happened? Oh yeah, I had to go, but the code ran. So that finished the code on that one, and it ran perfectly fine. So I just had to go really quickly, but just gonna jump into it. Valid Anagram, LeetCode easy, and yeah. So is anagram. We're given two strings S and T, and we have to return a Boolean. So given two strings S and T, return true if T is an anagram of S, and false otherwise. So if T is an anagram of S, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase, typically using all of the original letters exactly once. So basically, we could rearrange this problem as since an anagram A and B can be rearranged, A can be rearranged to form B, or B can be rearranged to form A, we can rearrange this problem as for all the subcontents of S, right, do we have the exact same matching or pairing of T? So if we look at a string cat and we were to map the letters and occurrences, we would have C one occurrence, A one occurrence, T one occurrence. Well, is tac an anagram of cat? Well, let's check. Let's create that mapping again, and then we can see that they are anagrammed. Tac is an anagram of cat, right? So to do this, right, what we really need to do is just check parity of letter and occurrence. So a map would come in very handy here to do that. But we could also I actually just forgot a way to do this in linear time, I think, or S plus T time, I think, is the best you can do, because you have to visit the entire character in both strings, all the characters in both strings, So that being said, how do you go about this? There's two methods. One would be I think S log T and T log S log S and T log T, and I think that's because the best we can do on a sorting is N log N. And so if we sort these strings, we would have to, assuming S is the length of the string, we do S log S and T log plus T log T. So I think a linear time solution would be actually to create a map Wait a second. If we have cat, I think I just might have figured out another way to do it. If we have cat and AAT, we'd have CAT111 and AAT. Now if you added all these together, you would get, if we were to like do, I guess, a union of the maps, you have C equals 1, A equals would be a equals 2. If a equals 3 and t equals 2. Now if we had tack like we originally said, have c equals 1, if we were to add these together, boom, boom, and boom. So I think you could just do a map of the occurrences for both S and T into one map. If we take account of the occurrences of all of them mod 2, that means we have at least 2 pairs of every character, and you need to have 2 pairs of every character if one string is an anagram of another string, right? I'm trying to figure out if there's any edge cases. I kind of just want to write the code and click run and check, but that's bad practice, I think, for practicing. I should be able to figure out exactly why this doesn't work before I run the code. So I guess we could try rat and car. We create some occurrences for these. Equals 1, c equals 1, a equals 1, r equals 1. To check if I was recording. Then we would have RAT and CAR. Now if you fuse these maps, we have R equals 1, A equals 2, and R equals 1, A equals 2, R equals 2 actually. T equals 1, and C equals 1. So one more thing we have to make sure is that the number of keys in the map matches the number of characters in both strings. So it does work, but the number of keys in the map have to match. The number of keys in the map would have the number of keys in the map would have to match the number of characters in the number of keys in the map would have to match the number of characters in both strings. Oh, buddy, the number of strings. Another case that I think this would work. I feel like this would work. So let's try and write that. So the goal for this hour, I think, would be S plus T time. If we create a map of S and a map of T, we could iterate over this map, and it would be constant space, because S and T consist of only lowercase English letters. So for any arbitrarily large strings of S and T, we'd use up 26 indices in the map. So do const map equals new map string number. We can do for const car of S. And actually, another thing we'll make sure, right? S is not an anagram of T if their lengths aren't the same, right? So if we have car and cart, right? They're not an anagram of each other because there's one extra character, right? So if we get past here, we know they're the same length. So for const car of S, we'll do const value. I'm sure there's a way to fuse both of these. Maybe you can do S dot. Actually, I'm sure we could fuse both of these together like this. Value, if the map has the character, right, then we want to get that character. And if it doesn't, then we want to return 0. And then for the map, well, we'll say set the occurrence for that character at value plus 1, right? And then here we can create a variable called count, and here we'll make sure to check that for the const of, let's just call it combined, and then we can cut this out here. Const car of, wait, actually, do we have to iterate over the, no. Yeah, actually, we'd like to make sure that for all occurrences of the map, we actually don't need to do const char of combine then. We could just do const, I think it's index and, no, it's key and value of map dot entries. Do we need the key? No, we don't need the key. We actually just need the value. So we'll just do it like this. And then to make it more readable, we'll change this to occurrence. So if occurrence mod2 equals actually it doesn't even, we don't even have to do an if case. We'll just do ct plus equal occurrence mod2, and this should equal 0 if there's an even number of all the occurrences, right? So if we had 2 cat and tack, all right, c equals 2, a equals 2, t equals 2. Mod 2, if you string all these together in addition, right, you should get 0 plus 0 plus 0 plus 0. 0 plus 0 plus 0. And then what we have to do is return if ct equals 0 and map.keys equals s.length. Or we can say, yeah, map.keys dot length. I didn't run it in my head for one, so I think we should be good to run it. Oop, I put const, just make another check for any const. Let, we're updating this, plus equals. Oof, property length does not exist on type iterable string. I think we can also just use size. Oh, so for anagram and nagaram, I return false. Oh, not map.size. Right, because we, right, so for example, if we had CAAT and TAAC, the map would look like C equals 2, A equals 2, I mean C equals, I'm going too fast today. We have C equals 1, A equals 2, and T equals 2. So we have 2 A's and 2 T's, and oh no, okay, yeah, I forgot, we're doing the map combined. So we'd have 2 C's, 2 T's, and 4 A's. If I do map dot size here, what I get is actually 3, right? And so what I actually want to check, I think this is where actually I got stuck last time. There's an easier way to solve this, but I really wanted to figure out S plus T solution. What I was trying to verify with map.size equal s.length. CT equals 0. Because there's a chance that we have something like CAA, for example, we have CAAT and CAAB. So if C equals 2, A equals 4, T equals 1, and B equals 1. Now with the current code, actually this does validate it. This would return false because CT wouldn't be equal to 0. So maybe I'm actually doing a redundant check here. But let's try a different one. If we did CAA, how about CAATT, right, and CAABB? So now we actually return CT does equal 0, but it's incorrect. Actually, maybe there's an even simpler version. I'm just trying to mimic something that is when something happens, the opposite of that returns it back to its original state. And I'm pretty sure I couldn't do it with a counter, like, because then I would just be adding, let's just say 4 characters, and if I pop a character on each iteration, I would end up with 0 characters, but it doesn't mean they can be rearranged. I think what I'm just looking for is a map, actually. I think this whole thing could be simplified if map.size equals 0. So it'd be actually the... Yeah, it's just... Actually, you could do it. No, but that wouldn't be as simple. I think map is what we're looking for with constant lookup. So the new plan would just be to iterate over both strings and iterate over the first string. We'd have a map, right, with C, A, T, T. So C equals 1, A equals 2, and T equals 2. And then now we would iterate over CABB, the string, and if the character exists in the map, then we'll set it to 0, right? And we'll decrement it, right? So C does exist in the map, we'll decrement it to 0. A does exist in CAAB, so we'll decrement it 1. A exists again in C in the map, so we'll decrement it again. T doesn't exist in the map. So as soon as we find a character that doesn't exist in the map, then we could just return false. Character that doesn't exist in the map. Character that doesn't exist in the map. So I think we should be good there. I think there's one more edge case. Character doesn't exist in the map. Yeah, I think that actually does work. Yeah, I think that does work. As soon as it doesn't exist in the map, then yeah, return false. I think we can actually change this to just return true, because this new function is going to fix this for us. So do const char of s. We don't need combined anymore. We'll still keep this top point because it's going to save us time. We shouldn't need ct equals 0. And then here we just have to not iterate over the map, but iterate over t. Const char of t. And now we have char of t, right? And we want to do a similar thing. So if map.hasChar, right? If the map has the character, ooh, I gotta use the bathroom very bad. If the map has the character, then we want to decrement it, right? So we'll get the occurrences. So map.getChar, get the occurrences, right? Now, if the occurrences, we'll get the occurrence -1, right? Because we're going to decrement it. If the map has a character, we're iterating over t. If the map already has the character from the first thing, we're going to decrement it, right? But if we decrement it and occurrences equals 0, then we actually want to delete the character from the map. So we're going to delete the key value pair in the map. Right? If the map ever doesn't have the character, so let's just say if we have 2 strings, our map looks like C equals 1, A equals 1, T equals 1, and we're iterating over bar, right? B, we'll just make it simpler and make it cat. So C does exist in the map, we'll set it to 0. We're going to set it to 0, and then we're like, wait, it's or we're gonna get the occurrences, it's 1, we subtract 1 from it and it's 0. Well, it's empty now, so we're gonna delete it from the map. A, 0, empty, delete it from the map. And then we're gonna get to, we're iterating over car. Sorry, I didn't say that, but we're iterating over car. Well, we're gonna check if R is in the map. Well, if R isn't in the map, then return false, right? They're not anagrams of each other. And if we make it out here, then we confirm that that T is an anagram of S. I think this should work. Nice. Whoa. Output true. Well, yeah, you can rearrange AACC. Oh, no, it's 3 C's. Right, I knew it. I knew it. There was one more edge case. If you have, this is only when there's 2 ways to fail the anagram check. One is if you use a character that doesn't exist in the other string. The other one is if the characters in both strings match, but the number of each other don't match. And that's where we need count. And we'll make sure count equals 0. So there's one more thing, and this is a lot of extra code to make this S of S plus T time, but I think it's really, it depends on, I don't even know if it's worth it or not, to be honest, but you could do that just by doing the destructuring of the map, the remainder of whatever is in the map, to be honest, and we'll just do CT plus equal occurrences mod 2. And if CT doesn't equal 0, that would solve this, because at the end of the map, you'd have 1 key which has 1 occurrence, right? That would be a problem. Oh yeah, you don't have to return true in CT. Return CT equals 0. So somehow we're failing for Anagram. That's strange. Why are we failing for Anagram or const car of T? Const car of T. I think there's actually a debugger in this thing. Oh, run. I know there's a debug in this thing, but I need to test something. Or maybe you can just run the code. I'm curious if occurrence is the actual occurrence, the error, the order of the tuples does matter, and I don't know if it's in the correct order. std out 3. Oh my god. Oh my god, I just realized what I'm doing. No, the code is fine. This is actually correct. I just had a brain blast. I'm just checking if the occurrences are 0 and then deleting them. The problem is that you actually have to decrement the index, right? If occurrence is 0, then delete it from the character, then delete it from the map, right? Otherwise, we want to do the map.set of car and set it to the decremented occurrence. That's why it said 3, because when it got to, I think, A, which is the third indice, the console.log output is 3. I think this is fine. Yeah, ah man, that's so bad. That's probably why it's better to go slower. So I'm still getting false for this AAC, CCAC. So my output is true. Oh my god. I'm doing anything. It should be the else case. I've done set car of occurrence. If I delete the if I delete, I mean, you can actually eradicate the else case if you just do the set first, but maybe it reads better. Well, what I was doing before, if the currents equals 0, then I'm deleting it, right? But then I'm going to set the entries again, so it kind of doesn't make any sense. Would that be why I fail? Let me think before I look. Actually, I guess that would be why I fail. Right, because if I can't find it in the map, then we return false. Now I'm curious if I even... just want to validate my assumption that I still need this section. I'm just going to return true. Oh, so I actually don't need the secondary part. That's interesting. I wonder... No, that actually... Yeah, I shouldn't need this part. No, yeah, I think you shouldn't need this part. I think you could design an input. So what was I failing on? If I go to the wrong answer that I had for this one. AAC, and this one had 3 characters in it. A equal 2, C equals 2, C1, C0, A1. Return. Right, I think you could actually design an input that would fail the current code. It's current test, the current code test. For example, this is where you have more characters than the input string. But what if you had an input that was like AACC and I only had AACC? My current code will return true that this is an anagram, but it's not an anagram. And I think I can test it. I'm just gonna write is anagram and call it down here. But I'm pretty sure maybe they're just exporting my function to use it. I'm gonna call it AAACC and AACC. So this is gonna return true, but it should return false, I think. And if I check I don't get any output. Maybe if I do console.log. Oh, it still returns false. That doesn't make any sense. Oh, I wonder if is anagram that I'm calling here is theirs, or if it's mine. So I'm calling is anagram here. I don't know the specifics of how they're all stringing this together. So this is not an anagram of it, and I'm returning false, but I actually don't know why I'm returning false. I'm gonna return false here, I'm gonna return false here just to see. Or I'm already returning false, so I wouldn't know. I'm going to return true up here, and this test should fail, but my test and standard out should say true. Okay, yeah, I knew something. Yeah, okay, so I'm returning true as soon as the function starts, basically, and I'm returning true here. My std out says my test is false, so I must be calling their is anagram and not mine, maybe. Let me test something. Yeah, I mean, I'm pretty sure you could, without this extra block here, then you could design input for this function to fail. But you know what, we'll take it. I wanted to do more problems, but I really wanted to get a S plus T solution. All right, so this is what I was saying earlier. You could convert it to a character array, sort it, and then just check if they're the same in linear time. Oh, we n log n bounded because you're bounded by the longest operation. Let me slow down. You're bounded by the longest operation here, which is going to be the sort of both strings. The frequency counter. Oh, this is what I did. Except they're not using a map here, they're using an array with 26 indices. And you get the character. Right, and they're pushing down the ASCII values of the characters by pushing it down from A, which should be ASCII value number 75, I think, or 76. That's pretty clever. And then at the end, they're doing the same validation step I was doing by checking what languages int count counter. Oh, I see. So for every index in this array, right, if count does not equal 0, so they're making sure that all the pairs have been matched. Okay. Unicode characters, mine would work for the map and Unicode characters. Good enough. We'll get to the other ones tomorrow, but this was fun to search the edge cases. But thank you for tuning in. And I think this is day 8 or day 9, so I will see you guys. I'll do the next one. I'll do the next one tomorrow.